We all use large language models,
Oh.
for getting quick answers, summaries, all sorts of things. But there's this persistent problem.
Yeah, the hallucination issue. Sometimes they just state something completely wrong, but sound totally confident about it.
Right. And it makes it hard to really fully trust them, especially for factual stuff.
Definitely. You need some way to know if the answer you're getting is actually reliable.
So figuring out why that happens is, well, it's complicated. But the research we're digging into today points to something pretty fundamental, maybe even a bit overlooked.
Time. It sounds simple, but think about the questions you ask.
Okay.
Some answers just don't change. Like, what's the freezing point of water? Always the same, right? At sea level, anyway.
That's evergreen. True yesterday, true today, true tomorrow.
But then there are other questions. What's the average global temperature rise since, say, 1850? That number changes.
Or who's the current mayor or prime minister or CEO of some company.
Exactly. Those answers are mutable, they change over time.
And that's where the trouble starts for LLMs, isn't it? If it was trained on data from last year, its answer about the current mayor might be outdated, wrong, basically.
Precisely. And this whole concept, whether a question's answer is stable or changeable, its temporality turns out to be super important for reliability. But surprisingly, it hasn't been explored that deeply in AI QA research.
That seems like a bit of a blind spot.
Yeah, most work focused more on like understanding dates within the question, not on this basic property of the question itself, is the answer fixed or not.
So today we're doing a deep dive into this paper called Will It Still Be True Tomorrow? It tackles this head on, this idea of question temporality.
Yep. And our goal here is to unpack how they define and classify these evergreen versus mutable questions. We want to see how well today's LLMs actually get this difference.
And crucially, how understanding this can actually help make AI more trustworthy, more useful for, well, for you, the user.
So the core problem is that LLMs can hallucinate, and it seems these mutable questions are a big driver of that.
Because the right answer isn't fixed.
Right. An LLM learns from its training data, which is like a snapshot in time. For a question whose answer changes, that snapshot gets old fast,
So to get the current right answer, it needs newer information than what it was trained on.
which often means needing to access external, up-to-date sources.
This really highlights why just classifying the question type matters so much.
Yeah.
It's not just difficulty, it's shelf life.
Uh-huh. And the paper points out this gap, that previous work didn't really focus on creating a solid way to just identify this evergreen versus mutable distinction across lots of topics and languages.
So what do these researchers do about it? They built something new.
They did. They created EverGreenQA. They call it the first multilingual, human-curated, evergreen-aware QA dataset.
Okay, multilingual and human curated sound like key features. What's actually in this data set?
It's got 4,757 questions, a mix of real user questions and some synthetic ones they added for balance. And importantly, humans labeled each one evergreen or mutable.
And they provided the right answers too.
Yep, the golden answers. They also made sure to balance it. Apparently, they needed to add more evergreen examples initially.
And the multilingual part, how many languages?
7. English, Russian, French, German, Hebrew, Arabic, and Chinese. So, a good mix, including non-Latin scripts.
How do they handle translation? That can be tricky.
They used tools like GPT-4 first, but then, and this is important, they had humans validate everything. For all 7 languages, makes it much more reliable for cross-lingual work.
Okay, so they have this solid data set. Then what?
Then they used it to train a tool, a lightweight multilingual classifier called EGE5.
Lightweight, that sounds useful. Means it doesn't need a supercomputer to run.
Exactly, more practical to actually deploy. And this little classifier, EGE5, it achieves state-of-the-art results for this specific task, just figuring out if a question is evergreen or mutable.
Better than the big LLMs.
Significantly better. Outperforms the 12 general-purpose LLMs they tested, and also previous methods that tried something similar.
Okay, so with this data set and the specialized classifier, EGE5, they could really start testing the LLMs. How aware are these big models of whether a question's answer might change?
Right. They looked at it in 2 ways, explicitly and implicitly.
Explicitly meaning you just ask the LLM straight up, like, hey, is the answer to what's the capital of France going to change?
Pretty much. They prompted them directly about the temporality, and some models like LMA 3.17AB and Quen 2.532B Did okay.
Yeah.
Reasonably well, actually.
But not as good as the specialized tool.
No, EGE5 was still much more accurate. One interesting point was that the LLMs were fairly consistent across the different languages when asked explicitly.
So they kind of get it if you ask directly, but it's not their main strength.
Yeah.
What about implicitly? Can you tell from how the model behaves, like how confident it seems?
That's what they checked next. They looked at internal uncertainty metrics, things like perplexity or mean token entropy. These numbers kind of reflect how surprised the model is by the words it's generating. Does high surprise mean it thinks the answer might be mutable?
And what did they find? Is uncertainty a good clue?
Not really, only mild correlations.
Mild correlations, meaning the model might be uncertain for lots of reasons, not just because the answer changes over time.
That seems to be it. Larger models showed slightly stronger trends, but still pretty weak. Overall, these uncertainty signals were noticeably weaker than just asking the model directly.
So you can't really rely on the LLM seeming unsure as a sign that the question is about something changeable.
Doesn't look like it. It's not a reliable indicator on its own.
Okay, so we've got the problem, the new dataset and classifier, and the finding that LLMs aren't great at recognizing this implicitly. Let's get to the payoff. How does knowing if a question is evergreen or mutable actually help? The paper mentioned 3 practical uses,
Right. The first one is about improving something called self-knowledge estimation.
which is basically the LLM knowing what it knows, and maybe more importantly, what it doesn't know. Key for trust, right?
Absolutely. And they found that if you take the probability from their EGE5 classifier, how likely it thinks a question is evergreen, and combine it with other uncertainty metrics.
It helps a model better estimate if it actually knows the answer.
Yes, significantly. It led to better self-knowledge estimation in 16 out of 18 evaluations they ran.
16 out of 18? That's pretty consistent. Any specific insights there?
Yeah, one really interesting thing was that the evergreen probability by itself was actually exceptionally good at one specific thing, identifying when the model does know the answer and is correct.
So if EGE5 says a question is very likely evergreen, chances are the LLM's answer is probably right.
That's what the data suggests. It's a strong signal for correctness. But it wasn't as good at the flip side predicting when the model doesn't know. If a question isn't evergreen, this signal alone doesn't tell you much about whether the model will get it right or wrong.
Okay, makes sense. Application number 2, filtering QA datasets. This sounds crucial for benchmarking.
It really is. Think about the standard test sets used to evaluate LLMs. Many were created years ago.
And the correct answers listed in those datasets might just be old news now.
Exactly. The paper gives examples about the next Olympics host city from a dataset made before it was announced, or the current mayor, attorney general, minister. These change.
Things like how many teams are in a sports league, population numbers.
Even details about people who are still alive, their job, their relationship status maybe, all of this stuff can become outdated.
So a brand new, up-to-date LLM might give the correct answer for today.
And get marked wrong by the old benchmark, which obviously messes up the evaluation.
How common is this problem?
They found these mutable questions averaged around 10% across the datasets they looked at. That's quite a lot, undermining the idea that these benchmarks are stable over time.
And does it actually affect the performance scores you see?
Oh, definitely. Model accuracy was consistently higher on the Evergreen questions, especially when the model couldn't search externally. Sometimes the gap was huge, like 40 percentage points.
What?
And it also showed that RAG, retrieval augmented generation, where the model can search, helps more for the mutable questions, which confirms they need that external, fresh information.
So the bottom line is you really need to filter these benchmarks, or at least be aware of the evergreen mutable split.
Yeah, for a reliable, fair assessment.
Okay.
And EGE5 gives you a way to do that automatically.
Okay, third application. This one was about GPT-4o and when it decides to use its search tool.
Right. GPT-4o can decide on its own whether to just answer from its internal knowledge or go look things up using retrieval. How it makes that choice wasn't entirely clear.
And this research shed some light on that.
It did. They found that whether a question is evergreen or mutable is the strongest predictor of GPT-4o using retrieval.
Stronger than other things, like the model's own uncertainty.
Substantially stronger. More than twice as informative, according to their analysis.
So GPT-4o is basically much more likely to go search the web if it thinks the question you ask is about something that changes.
That's the clear implication. Its decision to search seems really tightly linked to the temporal nature of the question. It sort of knows that mutable questions need fresh data.
Fascinating. Okay, so the EGE5 classifier is good, state-of-the-art even, but not perfect. The paper looked at its mistakes too, right? Error analysis.
Yeah, which is always important. They looked at false positives and false negatives.
False positives being it thinks a question is evergreen, but it's actually mutable.
Right. Examples included questions with superlatives like biggest star or healthiest tea. Those answers can change with new discoveries or research, but the classifier might miss that.
What else?
Questions about living people's work, Simu Liu movies, Stephen King works. Their output grows, so the answer changes, but the classifier might treat it as fixed. Also, questions that sound factual but depend on the current date, like asking about an election year or a future full moon date.
Okay. And false negatives. That's when it thinks a question is mutable, but it's actually evergreen.
Yep. And they actually found more of these. Examples were things like stable facts, oldest currency, rarest element, geographical facts like the area of Liechtenstein, biological constants like elephant species count.
Things that really don't change, but the classifier flagged them as potentially changeable.
Exactly. Even cultural things like where Ded Moroz, the Russian Santa Claus figure, lives, or historical events like the impact of the French Revolution, things that are quite settled, but the classifier was maybe overly cautious.
Interesting pattern that it made more false negatives.
Yeah, about twice as many. It suggests the classifier is, let's say, more hesitant to declare something a fixed, unchanging fact. It errs on the side of caution, maybe.
And why does it make these mistakes? Any clues?
Well, those superlatives are tricky. Lack of real-world knowledge is a big one, like knowing if someone is alive or dead changes whether questions about their works are mutable. Not knowing the current date makes questions about recent or future years hard, and just the general difficulty of distinguishing facts that are truly fixed forever versus those that could change, even if they haven't for a long time.
Right. So let's kind of wrap this up. The big takeaway seems to be that this simple-sounding distinction, evergreen versus mutable, is actually pretty fundamental.
Yeah, it's a core concept that really impacts how we build LLMs, how we test them fairly, and even how we understand their behavior, like GPT-4o's search decisions.
And the contribution here is creating the first proper multilingual dataset for this, EverGreenQA, and that lightweight, high-performing EGE5 classifier.
Exactly. It provides a research tool and potentially a practical component for improving AI systems right now.
So thinking about this for you, the listener, maybe the next time you ask an AI a question, especially if it's about something current or ranked, pause for a second. Is this question likely evergreen, or could the answer change? Recognizing it might be mutable could change how much you trust the answer immediately. Right, or maybe prompt you to double-check it, especially if the AI doesn't say where it got the info. It's another lens for evaluating the information we get.